Welcome to the shop. I'm continuing NQALHA Production Run 4, making more parts. Each NQALHA has 75 parts and I'm making 10 units, and that's 750 parts. So I better get going. I've already set up the machine because the setup is fairly repetitive, and if you're really interested in seeing how the setup is done, I do it in detail in the first video, possibly the first two in the series. But for right now, I set it up off camera. I'm using my standard setup of 2 vices for first and second operation, with the second operation being on a tooling plate, the first operation being the blank held in the vise, using the Tormach electronic tool setter to measure Z height. Z0 is at the top of the blank, X and Y0 left rear corner, everything standard. It's the way I do most of the parts. 0 on top of the tooling plate on the left vise, rear left corner. And here's something I haven't shown before. I'm using a semi-synthetic flood coolant called Trim Microsol. I think it's Microsol 600. And one of the important things that you gotta do when dealing with coolant is to periodically inspect it to check its proper concentration. So I've got a refractometer here, and I'm gonna go ahead and poop out some coolant. And go over under a light. And it's looking pretty close to correct. The data sheet recommends a 7% dilution for 7% coolant to water. And it's pretty close. It's like 6.8. So I'm probably not going to dick with it today, but it's important to keep the coolant concentration correct. I also installed a filter in the coolant line because the way my machine is set up, I have a mesh screen in the bottom of the machine stand, and supposedly the mesh is fine enough that it catches all of the metal particles, but occasionally a particle gets through, and I like to filter that out so I don't keep recycling particles back over and clogging up this little nozzle. So I've now checked my coolant, and this is like just about every part in this process. This is a known trusted tool path. This run of NQALHAs is almost completely identical to the previous one. I'm doing a little bit of optimization of tool path. I optimized the combo tool path on this one to try to minimize tool change and minimize work offset rapid change, but the parts are pretty much the same, and the tool path is pretty much known and trusted, but still, I treat every time I run a tool path like it's a new one and just try to be careful. Also, I've been having some trouble with the automatic tool changer, so I'm kind of paying a little bit of extra attention. It behaved very nicely all day yesterday, no problems, but I'm still going to be paying a little more attention than I usually do, just to make sure that it continues to operate correctly. So, standard setup procedure, standard operating procedure. Okay, tool change fine. 3-flute roughing cutter. Lakeshore carbide, the aluminum shredder. Pre-feed is correct. Feed is correct. Ramping in to try to avoid buildup 3 passes to get through 3/8 60-61, 5,140 RPM, 40 inches per minute. The aluminum shredder roughing cutter makes really fine chips, and the flood coolant does an excellent job of chip evacuation. When cutting a slot like this, cutter breakage can occur if you don't have proper chip evacuation. So I still haven't figured out the magic formula to avoid that little bit of buildup, so I just go over with the nozzle and kind of blow it off. Single step mode. Pre-feed correct. Feed correct. 15 thousandths. Finish pass. 30 inches per minute, 5,140 RPM. And it's a hell. So now I do make a bunch of these slugs. Wish I had something to use them for. I make a whole lot of them. Gonna check. This is just a quick sanity check. This is the hold down part. It's got a little ledge on it, and it's the hold down part for the next operation. And yes, it fits nice and snug. So sanity check passed. Gonna take this part out, put it on the paper towel, grab another blank, make sure there's no chips on the mating surface. Check the tool change to make sure the tool is being changed without breaking the little screws. Deburring the first operation part. So I'm setting up now for the combo tool path, and after this part is machined, I'll have one part on the prep table being deburred and cleaned, one blank in the first operation, and a part on the tooling plate being milled in the second operation, and then that will continue for the entire run. This part, each NQALHA uses 2 of them, so the run is going to be 20 parts. Tool changer is behaving very nicely, not misbehaving at all. Even though I'm fairly critical of the design of the automatic tool changer and consider it to be a borderline design at best, I've made several thousand parts with it successfully. So it does work. Just every so often it fails in very mysterious ways for reasons I don't fully understand. There's a lot of fiddly little adjustments that sometimes just drift out of adjustment. So using a 1/2-inch socket screw and a little aluminum washer so that I don't booger up the fixture too bad. Now, like the last one, this piece is only held in place by a single screw on its axis, and so I have to kind of like eyeballically and fingularly adjust and line up the piece to get it more or less straight. The piece is oversized, and it's pretty easy to get it lined up, so it's no problem. Get this guy on the paper towel, get the slug out of here. First operation, blank in place. So now I've readjusted and reoptimized the combo tool path to try to minimize tool change and work offset change. So this one actually will be first time ever running, so I have to pay a little bit of extra care, a little bit of extra attention here. Tool change correct. Single block mode. And that looks roughly sane. Or does it? It does. The toolpath program puts in a pre-feed height, a rapid to a pre-feed height, and it's usually about an inch above the surface, but sometimes it's inconsistent. I haven't taken the time to really look into it and figure out exactly what the distance should be, but you know, things are looking good. Doing the roughing pass. Throw the old eyeball on it. Now there's a very slight optimization that I could make there and save a half a second. There's a setting in the toolpath generator called minimize retract that would have eliminated that tiny little z-axis move. Okay, so that's correct. It doesn't turn off the spindle, moves to the correct work offset in approximately the correct place. Down, ready. Looking good. Ramping into the cut. Toolpath looking good. Blinking light on the GoPro, still happily blinking. I've had problems on previous videos where the GoPro decides to go on vacation and I don't notice that it's off, and then I lose my good audio quality. So now, still got a bit of rat nest on the cutter. Switching to the finish cutter. Tool change smooth and correct. Gonna check pre-feed correct, feed height correct, into position. Nice clean cut. I look throwing the old eyeball on the part to make sure that I have sufficient stick out on the cutter so that the collet nut doesn't hit the hold down screw. And no problem, everything's safe, everything's fine. And one thing I'll probably do is throw in a Z-axis or Y-axis move to the unload position, but hey, this tool path worked perfectly. So I'm going to run the parts and then turn the camera off and come back and do the third and fourth operations. So see you later. Back again. Got 20 parts finished with first and second operation, and I made a slight modification to the tool path for the third operation. I'm using a fairly long drill bit because, let me see if you can see it over there. I need to be able to drill through the entire length of the part here. So that's a pretty good amount of stick out, and I'd like the hole to be as accurate as possible to the position that it's intended to be in. And so I modified the tool path a little bit before it starts the PEX cycle to just really slowly, at 1/10 of an inch per minute, go down 50 thousandths and make just a little dot on top of the part. And we'll see if it works. So I'm going to go try it. I'm just going to do a dry run here and just see if it looks like it's going to be doing what I expect it's going to do. I'll turn the coolant off. That is going really, really slow. Not sure. Yeah, it looks like it's doing the right thing, but really, really, really slow. So, not sure it needs to be that slow. Going down for the second hole, and yeah, that's probably way too excessively slow. So, off to the CAD room. Speed that up a little bit. Yeah, I think I'm gonna like that. So this part needs a couple of things going on. Needs a drilled and reamed hole that goes all the way through the part like this. This is going to be, let me check my reamer as long as I'm here. Reamer looks good. This is going to be a hole for the axle. This is a magnet bracket that holds the magnet for the horizontal arm, and it needs to be able to flex up and down a little, pivot up and down a little on its axle. It also needs a counterbore, clearance hole, tap drill, and slot cut, because it's going to end up being a clamp that clamps the magnet in place. So, got my special spacer here, and going to put the part in place in the It's in the tall jaws. Get the tool out of the way here, clean up my area a little bit. So it's in the tall jaws, work offset 2, Z0 at the bottom of the vise surface. X and Y0 have been set with the Heimer. Most of the tool path is a known trusted tool path, but this new modification to start the drill is a little different, and like all tool paths that I haven't run for a long time, I'm going to be really careful. Looks like it did what I intended. Now, will that mean the hole is more accurate? I don't know, maybe. I'll measure them after I'm done. This hole doesn't have to be, I mean, it's nice to have everything accurate, but this particular hole, I want to make it as accurate as I can within reason, but it doesn't need to be perfect since the machine has an adjustment screw to be able to do a fine adjustment of the amount of angle that the bracket hangs down. So single step, verify pre-feed. Verify feed, 250 RPM. Reaming that hole. The drill is 1/64 undersize. It's a 1/4-inch reamer. And the pin that I use is a piece of 1/4-inch zinc plated rod, zinc from the manufacturer. Look at that. T2, 5/16. Forgot to load a tool. Putting just the tiniest bit of a counter bore just barely kisses the surface and hits the edge of the radius produced by the mill cutter. Let me look at the hole. Yeah, that's a reasonable counter bore. Looks reasonably good. So I'll go ahead and put that into the tool carousel after this operation is complete. So now the clearance hole, 1032 clearance. Throw the old eyeball on it to make sure that I have no conflict. This is not the tricky one. This is not the troublesome one. The next one, I actually had to switch from a stubby drill to a longer drill because I need to get all the way through the clamping surface with the 1032. Let me check. Looks good. Looks good. Looks good. Need to get all the way through the clamping surface with the 1032 tap drill. And the stubby that I had loaded before that just wasn't quite long enough. So that verifies that the tool path is correct. What I'm going to do now, before I start running parts, before I turn off the camera and go into production, I'll just give a quick demo of the next operation. So, kind of didn't have them, not totally prepared for this one, but only takes a second. So, once again, like in the other part that I did that had this same problem, I can't do a power tap operation because the tap isn't long enough, and the collet nut would hit the part, so I can't do a power tapping operation on this part. But since it has a clearance hole followed by the tap drill hole, it's the perfect candidate for hand tapping with the cordless drill, giving a perfect straight hole. Then I move over here to Mr. Bridgeport. Gonna put the old slitting saw in the Bridgeport, and this will not be done with power feed or CNC, but I do go over here and touch off the surface, set Z0 on the DRO, go over to the setup sheet and look at what the amount of distance is. And actually, when the motor is running on the Bridgeport, it makes it a little bit easier to do the fine adjustment on the Z. Kind of like dithers it around a little bit. So I stop the spindle as soon as the cutter breaks through, because I don't want to drag a spinning cutter back through the slot again. So there is the part. Uh-oh. There is the part. Looks good. All is well. On to production. I'm going to make 20 of them. Then, after that's done, they go in the vibratory polisher, which I tried to show on, I think, video 2. And it's noisy, it's boring, it's not really that interesting. It's an El Cheapo Harbor Freight vibratory polisher, so not going to show that one. And that's it for today. Thanks for watching.